Today we're going to be studying some more sophisticated exponent rules, and we're going to be studying exponents of exponents. The first rule is called the power of a power rule of exponents. That is when a to the power of m has an exponent of n. And that is going to equal a with an exponent of m times n. And I think I can show that to you with this simple example here. You see, this exponent 2 is associated with the variable. This exponent here is not associated with any variable. It is associated with the parentheses. It is associated with everything inside the parentheses. Therefore, it's a squared to the cubic exponent. And that will be a to the 6th. That is a to the 2 times 3. We didn't add it this time. We only add exponents when the exponent is associated with the variable. And of course it has to be the same variable. We can't mix a and b or a and x, something like that. But let's just say we have a series of a's with variables. As long as we're multiplying the variables times each other, we add the exponent. But we had an exponent of 3 that was not associated with the variable. It was actually associated with the exponent. It's a power of a power, or an exponent of an exponent. Let me show you how that works. Now that is our original problem. A squared to the power of 3. Now what is squared? The a is squared. But what is cubed? What is to the power of 3? It's not a. It's everything inside the parentheses. So a squared is to the power of 3. So let's take everything in the parentheses and multiply it by itself 3 times, which is what the power of 3 means. So we're going to take a squared and multiply it times itself 3 times. So there you go. If you take a squared and multiply itself times 3 times, now we can add the exponents, and that's 2 plus 2 plus 2, which gives us a to the 6th. You see how that works? So a squared to the power of 3 does not equal a squared times a cubed. You see, this cubed is associated with a variable. This cubed is not associated with the variable. So when you see an exponent that is not associated with the variable, watch out. This is probably what is happening, not this. Next is the power of a product rule of exponents. So that a times b to the power of m would equal a to the m, b to the m. Okay, let's look at how this would play out. But before we see how this would play out, let's look at this exponent. Every time you see an exponent, you should ask yourself a question. What is that exponent associated with? Now look at this. What is this exponent associated with? Well, in the previous lesson, every time we saw an exponent, it was associated with the variable. And we just saw in our previous 2 examples that it's not necessarily associated with the variable. It might be associated with another exponent or something else. This exponent is associated with the parentheses. What does that mean? It means the exponent applies to everything inside the parentheses. Now all these problems that we're going to be doing today, if you look at it that way, it's a lot simpler. So it's going to be associated with which one of these variables? Well, I just told you, everything inside the parentheses. What's inside the parentheses? The a is inside the parentheses. Well, that means that exponent is going to apply to the a. The b is in the parentheses. Well, then that exponent is going to apply to the b, just like this. Now be very careful because it is very common to apply that exponent to the variable that it's closest to. It applies to everything that's inside the parentheses. Now, before we move on to our next rule, let me show you something. A plus b squared does not equal a squared plus b squared. There's a different rule for that. And we're not going to show you how that works today. We are in the future, but not today. Just know that a and b need to be multiplied times each other or divided by each other. It can be a divided by b, and we're going to get into that. But they have to be attached to each other. So it's ab or a over b. And that would be attached to each other. But if it's a plus b or a minus b, this doesn't work. And there's a different rule for that. And I'll show you how that works later when it's appropriate. But let me show you the quotient rule. The power of a quotient rule of exponents. A over b within a parentheses to the power of m equals a to the m over b to the m. And this really works exactly like the product rule works. What is that exponent associated with? The answer is everything inside the parentheses. It is not associated with just the a. Very common mistake, and you end up with a cubed over b. No, it's associated with everything inside the parentheses. So what is that going to look like? It's going to look like that. And let me show you why that is the case. A over b cubed is a over b times a over b times a over b, and that would equal a cubed over b cubed. The same answer that we had before. Now let's look at some more complicated problems using these rules. Okay, we have x cubed, y, and z squared, and all of that to the power of 4. All of that to the power of 4 because it's all in a parentheses. What does that 4 apply to? It applies to everything inside the parentheses. It is not associated with the variable, it's associated with the parentheses. And so what we're going to do is, well, the first thing we're going to do is put a 1 behind that y, right? You don't see an exponent. There is one there, but it's understood. What's it understood to be? 1. And you're going to want that 1 there because that'll help to remind you that we're going to multiply that 4 times every one of those exponents. And you don't want to be thinking that y is 0 or y is just leave it alone. So what are we going to end up with? We're going to end up with x to the 12th, y to the 4th, and z to the 8th. Now let's do a division problem, and you're going to see that it works exactly the same. What is going to be squared here? Everything in the parentheses. Now, first off, let's put a 1 behind that b. Now I'm not going to do this variable by variable like I did last time. I'm going to do this in one fell swoop. So that's going to be a to the 6th times b squared over c to the 8th times d to the 10th. And that's the solution to that problem. Now let's try another. Okay, when we cube this, that is to bring it to the power of 3, we're going to have 4x6 and y to the 15th. Correct? No. What does that 3 apply to? What are we going to cube? Just the variables? No, it applies to the coefficient also. Now be real careful because that is something that is a very common mistake. And it's like you get really used to applying these rules to the variables, and then you forget that the same rules apply to the coefficient. So we end up with 4 cubed x to the 6th and y to the 15th. Now we don't know what x to the 6th is, we don't know what y to the 15th is, but we do know what 4 cubed is. 4 times 4 times 4 is 64, and that is our solution. Now let's try another problem. Well, we haven't seen anything like that before, but we do have a rule that we can use to help us out. What's the rule? Well, if you said PEMDAS, you are correct. PEMDAS is what? Parentheses first, and then exponents. So let's do all the work within the parentheses first before we apply this exponent. And that will give us 20x7y3. And I hope you'll forgive me, in that first problem I didn't put a 1 after the y. So you can remember to do that in your head, or you can write those ones down. I may do both from here on out, and you do what helps you to remember. I teach a lot of students some really basic stuff, almost baby steps, and there's nothing wrong with using those baby steps if they help you to get the answer right. But anyways, we have 20x7y3 cubed. So we're going to apply that 3 to all 3 exponents. To y3, that'll make that 9, and x7, that'll make that 21, and we'll put a 3 behind that 20. That's good, and of course we multiply out our coefficient. 20 times 20 times 20 is 8,000. And I'm going to show you how to do that faster. If you used a calculator, I'll show you how to do it even faster than a calculator. When you multiply numbers with zeros, just add up all your zeros, 1, 2, 3, and put them in your answer. And 2 times 2 is 4, and 4 times 2 is 8. There you go. I hope that's easier. If it's not easier, just use your calculator. Now let's try another problem. Oh, well, that's not that complicated, but it is messy, and so we need to attack this again with PEMDAS. What are we going to do? We are going to do the parentheses first, nothing to do in here. Then the exponent of the parentheses next. Oh, there, that's a little better. And of course, we need to apply that exponent to the coefficient. 2 times 2 times 2 is 8. And now we're going to multiply everything out, because there is no power of a power anymore. There's no exponent of an exponent. Everything is going to be multiplied times like terms. So 7 times 8 is 56, and 8 cubed times 8 to the 12th is 8 to the 15th. So it's 56 times 8 to the 15th. I hope you remembered to add those exponents and not multiply them. And let's try another problem. Okay, we threw in some division there. We do not have a power of a power in there, so we don't need to worry about exponents of exponents. So why don't we just tackle this one thing at a time. Let's take the top. 3 times 10 is 30, so let's multiply our variables. And maybe before we do that, we'll put a 1 right behind the b. There you go. And since we're multiplying variables with exponents instead of exponents of exponents, we're multiplying variables with exponents. We are going to add the exponents. Okay, that's a little lopsided, but that's okay. And let's divide our numbers first. 30 divided by 2 is 15. And a to the 7th divided by a to the 4th is a to the 3rd. Don't forget, maybe we've done so much work that you've forgotten that rule already. But when we divide variables with exponents, we subtract. Just like we add them when we're multiplying, we subtract them when we're dividing. So 7 minus 4 is 3, and that would be 8 cubed. And b to the 4th over b to the 2nd is b squared, and that is our answer. Let's do another problem. Oh, wow, that is a mess. we've got a parentheses inside of a parentheses. And we have a power of a power of a power. Wow. And we don't have any rules on how to deal with that. And guess what? We don't need a rule on how to deal with that. If we just attack this with PEMDAS, we're going to be okay. So what are we going to deal with? PEMDAS says parentheses first. Which parentheses? The innermost parentheses first. Okay, so let's apply this cube, let's apply this exponent to everything inside the parentheses. Everything inside the parentheses. Nothing outside of the parentheses, okay? That cube, that exponent, applies to the parentheses and the parentheses only. So let's worry about what's in the parentheses. Let's apply it. Well, good. One of our powers is gone, so now we just have a power of a power, which we know how to deal with. But we don't even need to deal with that right now. Everything in the parentheses is taken care of except the coefficient. The numeric value, the coefficient, has a power of 3. So what's 2 cubed? 2 times 2 times 2 is 8. And so everything in the parentheses is taken care of. And we can start multiplying everything, because there's no powers of power. Okay, there's just regular exponents, the regular variables with exponents. So now we can start multiplying these two terms here. 3 times 8 is 24, and all of a sudden I see a variable without an exponent. Let's put a 1 behind that first a. So 8 to the 1 times 8 to the 12 is a to the 13, and b squared times b to the 6th is b to the 8th, and all that's a little lopsided, but that's okay, we're used to that. And we're still working within this second parentheses. We're working within it. We got rid of the first parentheses here. Now we're still working within this before we apply what's outside of the parentheses. So 24 divided by 6 is 4, and a to the 13 divided by a to the 5th is a to the 8th, and b to the 8 divided by b to the 7th is b to the 1. Now, if this was our final answer, we would take that 1 off, but we're still working, so it is needed. And all of this inside of this parentheses, remember this gigantic thing that we whittled down to this? All of this within the parentheses is subject to this exponent. We're going to square everything. And it will look just like that unless you're working out of the book. Mr. Wallace doesn't like to put exponents behind coefficients. Most people don't. I do. It reminds you of what you have to do, and I don't like skipping steps at all. And 4 squared is 4 times 4, which is 16, and that is our answer. Now, what we just did is really not that hard. It's just really involved. It's a lot of work, and worst off, there's a lot of places to make a mistake. And there's a rule in algebra. If you have to do 20 steps and you get 19 steps correct, you've got your answer wrong. So you need to be real careful with each step. Check your work. When you're all finished, go back and check to make sure you did everything right, especially something as involved as this. Something as involved as this. Try not to write over yourself. Try to bring everything down and rewrite everything. That makes it easier to check. And it also makes it easier to do your work because you end up with just scribbles over scribbles over scribbles, and it's real easy to get lost. It's real easy to miss steps, and it's real easy to get the answer wrong. And the best way to get all your answers right is to do your homework.